AI agents are, well, they're no longer just science fiction, are they? They're the smart assistants in our phones, the tools that synthesize data, even the brains in self-driving cars.
They're everywhere. And they handle this incredible complexity almost invisibly.
Exactly, invisibly. But if you actually try to look under the hood, what's the fundamental anatomy? How does an abstract goal turn into a real-world result?
That's the question.
So today, we're moving past the marketing hype. Our mission is a deep dive into that core three-part structure of any AI agent: sensing, thinking, and acting. We're going to show you exactly how a system takes in data, processes it, makes a call, and then does something.
And to really ground this, we're using a task that is, I think we can all agree, surprisingly stressful for a human.
Oh, for sure.
Autonomously booking your travel reservations for a business trip. This isn't just a simple search. It's a high-stakes goal that forces the agent to balance what you want against what the company demands.
It's the perfect test case, really. It shows all three phases working together.
It does.
Okay, let's unpack this. We have to start at the beginning, phase one. Sensing. Perception. The agent needs inputs, just like we have eyes and ears.
Yeah.
So how does it gather that information?
Well, its perception layer is built to handle a few different kinds of data. The most common one is just direct text.
Right, like typing into a chatbot.
Exactly. That relies on natural language processing, or NLP. You type, "Book me a flight to Denver next week," and the NLP figures out what you actually mean.
It extracts the key bits of information.
Precisely. But sensing goes way beyond just a typed prompt. You can have physical inputs, think cameras or microphones, like in an autonomous car reading the road.
Okay, sure.
And crucially, for something like scheduling, you rely heavily on external APIs or data streams. These are like the agent's digital ears constantly listening for events.
What kind of events?
A new calendar notification, an email confirmation, anything that signals something has changed in the world it needs to know about.
So let's apply that to our travel booking example. The sensory inputs here are pretty concrete. What's the absolute minimum the agent needs to know to even start?
It needs the basics. The dates of travel, when you're going, when you're coming back, and the destination. That's it. Those are the essential inputs it has to extract.
And how it gets that information really defines how smart the agent is, right? A basic one just waits for me to type, "I need to go to London from June 5th to the 10th.
Right. But a truly smart agent is more autonomous. It's proactive.
How so?
So imagine the agent is integrated with your work calendar. It sees a new entry pop up. Quarterly board meeting Singapore. It's scheduled for October.
So it's not even waiting for me to ask.
Not at all. The sensing phase is reading that input directly from the calendar's API. It instantly pulls the destination and the dates, and that triggers the whole process. It shifts right from perception into the really hard work.
That proactive awareness is the trigger.
Okay.
So the agent senses the facts, Singapore, October, board meeting. Now it moves to phase two, the thinking stage.
The reasoning core.
Right. But before it can reason, it needs context. It's not enough to know where and when. It has to know who you are and what the rules are.
And that's where the complexity just explodes. The thinking stage is layered, and layer one is the knowledge base.
The knowledge base.
This is where it stores essential facts, rules, and most importantly, context. This is what makes the agent feel personalized to you. It might use a standard database, but often it's using something called retrieval augmented generation, or RA.
Let's pause on RAG for a second. Why is that retrieval part so necessary here? I mean, why can't the big brain, the LLM, just know everything already?
Because travel is so dynamic and so personal. A general LLM knows geography, sure, but it doesn't know your flight history or your company's discount code with a specific airline.
Or the price of a hotel room right this second.
Exactly. RAG lets the agent check its own internal library, like your company's travel policies, and then also look at external real-time data before it gives you an answer. It bridges that gap between general knowledge and the specific facts of right now.
So this RA system is what powers the personalization.
It is. It accesses your stored data, your preferred airlines, your loyalty program numbers, whether you need a vegetarian meal on the flight, all of it.
And this is where it gets really interesting, because the source material shows just how detailed this context can get. It's not just, "I like Hotel X."
No, it's incredibly granular. It can include these highly specific, location-dependent preferences.
Give me an example.
Okay, let's stick with that Singapore conference. The agent looks at your profile and sees two key preferences. First, you prefer the EcoStay hotel chain. Simple enough.
Right.
But second, it sees a stored note. When you travel for more than 3 days, you require a location that's good for a daily run.
Huh. That's very specific.
It is a park, a coastal path, something like that. That's high-level, very human preference data. So now the agent has to cross-reference this. It pulls up a map that's an external lookup, and it checks.
And it finds an eco-stay hotel right near a great running path.
It does. But it still can't book it yet.
Why not?
Because it's only satisfied one layer of the context, your personal desires.
Ah, right. This brings us to the second layer of context. Policy and constraints. This is business travel. The agent has to follow corporate law, so to speak.
Absolutely. The policy information is the critical firewall. For a big company, IBM, or any large business, this system must follow the guidelines. This means strict cost caps.
A maximum hotel spend per night.
Right, which changes depending on the city. It also means prioritizing preferred travel partners, so only booking flights with airline A or B, and maybe rules about travel class based on flight time.
So the agent knows you want that hotel with the perfect running trail. But now it hits this corporate firewall. How does it handle that friction? Does the policy just automatically win every time?
That is the entire point of the thinking stage. It has to perform this really sophisticated conflict resolution. Let's say the hotel you want, the one near the trail, is $350 a night.
Okay.
But the corporate cap for Singapore is $250. The agent can't just book that. It has to process its options.
Which are what?
Well, option one, find a fully compliant choice. Maybe there's a preferred partner hotel for $240 that's a short taxi ride from a park. That's a compromise.
Option two.
Find the closest match that barely breaks the policy. Maybe the running hotel is only $260, just a little over. It could flag that as a minimal breach.
And if neither of those work?
And then option three. If no good options exist, it has to either escalate according to a specific rule, or it generates a list of the best fit constrained choices for a human for you to review. It never just gives up.
That sounds almost like human-level strategic thinking.
Yeah.
How does the technical part, the reasoning core, actually do that planning?
It's using massive scale if-then-else logic, all powered by the LLM. It takes the high-level goal, book Singapore trip, and breaks it down. We call it task decomposition.
Into what kind of smaller tasks?
Find flights, check hotel eligibility, cross-reference prices against the cost cap, check seat availability. All these subtasks are probably running in parallel.
And it's learning as it goes.
Yes, through things like reinforcement learning. It constantly learns which sequence of actions leads to the highest satisfaction score. And a high score means following the policy while getting as close as possible to what you wanted.
And it uses chain of thought reasoning, which is a great phrase for this.
It is. It means the agent doesn't just give you an answer. It can explain its work.
Show its math.
Precisely. If you ask it, why did you book this specific hotel? It can trace its logic. Input was Singapore. Preference was running access. Policy was max $250. Hotel X was $350, fail. Hotel Y was $230, pass, and had gym access, a partial match. Decision, book Hotel Y.
That transparency is key. It proves it considered both my running trail and the company budget.
Exactly.
So the thinking phase is all the heavy lifting, resolving that tension between human desire and corporate rules. Once a decision is made, we move to phase three, acting. What does the generative part look like?
Well, the thinking phase culminates in an action, an output that actually affects the external world. Abstractly, this could be generating text or speech. In a physical system, like a car, it's turning the steering wheel.
But in the business world?
In the business world, the most critical action is talking to other computer systems. It's reading or writing to external databases.
Which, in our travel example, means the ultimate action is to book the reservation.
That's the one.
And that must be incredibly complex, dealing with all these different third-party systems.
It's the final test of usefulness. The agent has to interface directly. It has to, speak the right language to the airline's reservation system to buy the ticket and apply the corporate discount code.
Then do the same for the hotel.
Right. It then has to talk to the hotel system to guarantee the room and get a confirmation number. And if any of those actions fail, say the flight sells out just as it tries to book, that failure signal gets sent straight back to the thinking phase,
triggering it to replan immediately.
Immediately. So the successful result, the output we actually care about, is the electronic ticket and the confirmed reservation landing in your inbox. The loop is complete.
But, as we said, a good AI agent isn't static. If it stopped there, it would just be a transactional tool. What makes it continuously valuable is what comes next, that essential continuous feedback loop.
The feedback loop is vital. It's what ensures the system doesn't just succeed once, but that it continuously improves its definition of success. It has to learn.
So how does it measure success? Is it just Did the reservation go through, or is it something more?
It's much deeper. One of the main ways is through reinforcement learning with human feedback, or RLHF.
Which means it asks me how it did.
Basically, yes. After the trip is booked, or maybe after you get back, the system might send you a quick survey. The hotel followed the policy, but did you enjoy your stay? Did you actually get your run in?
A thumbs up or thumbs down.
Exactly. Your response is direct reinforcement. If you give it a thumbs down because the running trail it found was closed for construction, the agent learns. It learns that specific combination of factors leads to low satisfaction.
And next time it might prioritize differently.
Or it might add a new step to its process, like checking local park schedules through another API before it recommends a location.
That's a lot of subtlety. What about self-correction? Can it evaluate its own performance without my survey?
Oh, absolutely. The agent can perform its own self-evaluation. It compares the final output to all the initial constraints. Did the final cost go over the cap even by $1? If it did, why? It can even run hypothetical scenarios in the background.
Like what?
Like, what if I had chosen the cheaper airline? Would the total trip time have been acceptable? This kind of self-reflection is constantly tuning the weights in its reasoning core.
So the goal it's optimizing for it gets more and more nuanced. Not just book the trip.
Right. It becomes book the trip with the highest user satisfaction while hitting 100% policy adherence and maybe minimizing cost by X%.
So what does this all mean for us? The goal of all this continuous tuning is just optimization. The agent gets smarter, more personalized, and way more effective at this really complicated balancing act
It is a balancing act.
between our personal desires for comfort and the rigid constraints of a corporation. And it does all that so you, the user, can just focus on the real work you need to do when you finally land in Singapore.
Exactly. We've really seen how that structure sensing, thinking, and acting, all supported by this dynamic knowledge and strict policy, lets these agents move beyond simple tasks. They can operate autonomously in these complex, rule-bound environments.
So here's a final thought. If an AI agent can successfully navigate that core conflict, balancing a deeply personal preference like finding a good place for a daily run with a strict corporate policy like a cost cap, what's next? What other truly complex, rule-bound, human-intensive decisions could these agents fully automate, freeing up even more of your strategic time? That's definitely something to think about while you're settling into your compliant yet surprisingly comfortable AI-booked hotel room.